Now this means that the electrons which have left the valence band have occupied these many states in the upper band where it had the empty states were available, leaving behind the empty states in the valence band, that is the lower band. Both of these valence band and the conduction band are the allowed bands, which we get from the chronic penny model, separated by this forbidden gap. So in actual, the valence band and the electron band is not demarcated by a straight line. The distribution looks somewhat like this. It's a parabolic distribution. So as I said, that because the electrons which have jumped to the conduction band, leaving behind the empty spaces, are symmetrical in distribution. That is, the electrons with the plus k momentum will cancel out with the electrons with the minus k momentum, and the net current would be 0. But what would happen if external force F external is applied? What would happen if F external is applied? Now, the electron electron motion will have some definite the electron motion will have some definite momentum, and maybe the distribution, which I'll roughly draw here, if it looked previously like this, these electrons in the conduction band, these were the electrons in the conduction band when no external force was applied, that is 3 electrons with the plus k momentum and 3 electrons with the minus k momentum. Now if we have the external force which is applied, this scenario would change, and maybe there is a kind of an empty space here, and there will be asymmetric distribution of electrons, and these 2 electrons may go to this side, so that there is a net motion of electrons towards in the minus k direction, because this is minus k and this one is plus k. So we can say that when F external is applied, there is a net motion of electrons, and which gives rise to the field. Now we can write it as force into distance, that is, if dx is the distance traveled by the electrons, and it will go down to F into V into dt, where V is the velocity of the electrons and d of E is the increase in energy. And if we write it in terms of the summation, we can write the current density J as minus E summation I equals to 1 to N V of I, where Q is the E is the charge of the electron, N is the number of electrons per unit volume, and V is the drift velocity. So this occurs only under the condition when external force is applied.